Okay, problem 5. So for problem 5, I would like you to make a little drawing of how is this. So this is a lot of like very easy. We just need to read the problem and understand it. So a bird takes off from a perch and flies at a constant speed in a straight line. The position of the bird in flight relative to its nest can be described by the vector equation. Relative to its nest, that means that when t equals 0, uh, sorry, that means that when t equals 0 is in the perch, ¿no? O sea, in t equals 0 is where the perch is. And relative to its nest means that the nest is in the origin. O sea, a ver, let me make a drawing. O sea, like imagine that, so like here, I'm gonna draw the nest of the bird. Here is the nest of the bird. Like the tweeter bird, now X. And here is and here this would be the position, the nest, because it is relative to its nest. The position of the nest is 0, 0, 0. And now the perch, where the bird is starting the flight, is gonna be here in here is the perch, no, and here is the 18, 4, -2. And from here, the bird is taking a flight. O sea, like actually my bird is not in his nest, no? So just like the bird is here. Here is the nest, here is the bird. So what is the distance? O sea, I know that in the origin, in the 0, 0, 0, is where the nest is because it says relative to its nest. And I know that the perch is in this position because this is the initial position. And they are telling me that it takes off from the perch, no? Okay. So what is the distance between the nest and the perch? I just need to find like the magnitude of like this vector, no? So for problem 1, I just need to find the magnitude of this vector, which is very easy. You can do two things. You can either use the magnitude formula, o sea, that is 18 squared plus 4 squared plus -2 squared, square root, or use the calculator and use like norm 18 for -2. Both of the options are great. Both of the options should give you rounded to three significant figures, 18.5. It is 18.54 rounded to 18.5. What is, and now be careful, because here they are telling us that all displacement are given in meters and in minutes. And now they are asking me in kilometers per hour. So what is the speed? First of all, remember that the velocity is telling me two things. It is telling me the direction, and it's telling me like how fast the bird is going. No, that is why it is a vector, because vectors have magnitude and direction. So from the velocity vector is where I'm gonna take the speed from. No, remember that the speed, o sea, this is not a formula that it's in the booklet, it's a thing that you need to remember. The speed is the magnitude of the velocity. So you find the magnitude of the velocity vector, which is this is my velocity vector. And if you find it, you will find that you can again use the formula from the booklet, or you can use the calculator, and it will give you that it is 504.1914. But this is meters per minute, no? Okay, and now this is like a physics problem. How do you change meters per minute into kilometers per hour? That is a thing that I could ask you to do. So just remember that 1,000 meters is 1 kilometer, and 60 minutes is 1 hour. So I am gonna multiply by 60 minutes, and I am gonna divide by 1,000 meters, no? So that it turns in, so that this becomes kilometers per hour. Well, o sea, like 60 minutes over 1 hour. No, so this is how I turn it into meters per hour. And then if I multiply 1,000 meters over 1 kilometer over 1,000 minute 1 kilometer over 1,000 meters. No, so like I am just writing it like this in case that you don't remember how to do that from like middle school. This way you cross out minutes with minutes and meters with meters. So the answer will be in kilometers per hour. And what do? You multiply this times 60 and then you divide the answer by 1,000. And that is 30.3 rounded to 3 significant figures, kilometers per hour. Nice. Then I am talking about another bird. Bird. The bird is the word. Don't you know about the bird? Well, everybody knows that the bird is the word. I am asking you to find the distance between the two birds after 8 minutes of flying. So this is a very easy problem. So where is the first bird, the blue bird, located after 8 minutes of flying? Well, he is in this equation when t equals 8, no? So this position is 18, 4, negative 2 plus 8 times 272, negative 360, 225. And my other bird, let us draw it orange. This orange bird, where is it located? Well, in t equals 8 is going to be, because this orange guy follows this equation, he's going to be in the 12, negative 8, negative 3, plus 8 times this number. And what I want to find is the distance between these two guys. So do the math. O sea, you need to do 18 plus 8. O sea, this is 18 plus, o sea, I'm just going to write it for this guy. This is 18 plus 8 times 272. 4 plus 8 times negative 360. And negative 2 plus 8 times 225. And that is what? That is a big number. That is a big number. That is 2194 negative 2876 1798. Okay, you do the same for this vector, and that is also a humongous number. 84, negative 3512, and 637. Okay, and to find the distance, you can use the distance formula. No, remember that the distance formula is in your booklet. That is x2 minus x1 squared. So you would be doing x2 minus x1 squared, o sea, the difference between those two squared, y2 minus y1 squared, o sea, the difference between these two guys, and finally, you would do this is a plus, c2 minus c1 squared, and that is the difference between these two guys squared. Add it up, do the square root. The answer is 3910, rounded to 3 significant figures. Nice. Problem 5. Woo!